let's go to page 458, and let's start with number 1. Okay, so read through the problem. So this is a decay problem, but let's go and write down all the information. So you have the half-life is equal to 3.8 days, and you have the starting amount is equal to 5 grams, and you're looking for the final amount, and up to 4.2 days, so t equal to 4.2 days. And so then write down the equation you need to use. So this is the decay problem, so use the decay formula. Then you substitute whatever it's giving. And punching all the numbers in the calculator, you get x equal to 2.32 grams. Okay, let's go to number 3. Okay, number 3 is read through, and this is the investment problem. Okay, so starting amount is 10,000, and then the interest rate is 0.12, 12%, and it compound monthly, so 12 times in a year, and the final amount is 30,000, and the time is what you're looking for. So how long will it take to triple the amount? Okay, so this is the investment. So write down the investment equation, the compound interest equation. Substitute everything in here. Okay, now for this one, the variable is in exponent position, so you need to go and get rid of all the stuff here first. So divide by 10,000. So you got 3 is equal to 1 plus, you can go and simplify this part already. So this will give you 1.01 to the 12t. Now because this because the variable is an exponent, so you need to go and take the log on both sides. So you got log 3 equal to log of 1.01 to the 12t. Then this can come to the front. And then after that, you have to divide by 12 log of 1.01. So that all this will cancel out. So use your calculator. Now everything on the bottom, when you enter in the calculator, you have to divide. So you have to use log 3, divide by 12, divide by log of 1.01. And so you're going to get 9.20 years. Now if you want to convert it to years and month, that's fine. So you can leave it like that too. Okay, let's go to number 5. So this one has 2 parts. Okay, so it tells you, first part is that up to 50 years, the population double. So population double means the final. So the final equal to 2 times original, right? So the end equal 2 times starting. So that's what double means. So from here, what you need to do is, using this information, you need to find the constant k. Okay, so you got n equal to n0 times 2 to the kt, and so n is 2 times n0 and k times 50. Okay. So divide by n0 on both sides. So you got 2 equal to 2 to the k times 50. Okay. So by matching, this means this is 1, right? So by matching, you can see that 1 is equal to 50k. So k equal to 1 over 50. So once you find k is a constant, so it will not change. It will stay the same throughout the problem. Okay, so once you find k, you want to update your equation. So you got n equal to n0 times 2 to the 1 over 50t. Okay, so that will be an updated equation. Now you can go and use this to solve whatever problem you have, right? So now it asks you how long, so you're looking for t. How long will it take to triple? That means the end equal to 3 times the beginning. That's what triple means, right? Again, the end equal 3 times the beginning. Okay, that means tripling. So now you can put this in here to go and solve for the time it will take. So you got 3n0 equal to n0 times 2 to the 1 over 50t. Okay, so divide by n0, divide by n0. So you got 3 equal to 2 to the 1 over 50t. Now, over here, they are the same base, so you can make a comparison and solve, but this one is not. So you have to take the log on both sides. Because the variable is an exponent, so you have to take the log so that you can bring it down. Okay, so once this is in the log form, the exponent can come down now. Okay, again, the purpose of bringing down the variable in the exponent is taking the log. So you got 1 over 50t log 2. Okay, bring this down. Okay, and the next I'm going to do is to solve this, I'm going to multiply by 50 on both sides. So I got 50 log 3 equal to t times log of 2. Then I'm going to divide by log 2. Okay, and again, when you use calculator, you have to use 50 times log 3 and you have to divide by log 2, and then you will get 79.2 years. Okay, let's go to number 7. Okay, so this is the investment problem. So it paid $4, so that's the end amount. So A is $4 up to 5 years. So T equal to 5 years. Okay, for every $3 invested, so that's P equal to $3. Okay, so again, the end and this is the beginning, right? So to the nearest percent, so you're looking for R. Okay, of what annual interest rate compounded quarterly. Okay, compounded quarterly, that means n equal to 4, because quarterly means you compound it 4 times in a year. Okay, so that's what you have. Okay, so this is a compound interest problem. So write down your equation for compound interest. So substitute everything in here. Okay, R is, you don't know, n equal to 4, and n times t would be 4 times 5. Okay, so in this case, you can divide both sides by 3 first. So you got 4 over 3, so this cancel out. So you got 1 plus r over 4 to the 20 power. Now this one you don't take the log because the variable is not in the exponent. Okay, so to solve this, first you have to get rid of the exponent. So raise it to 1 over 20th power on both sides so that this will cancel out. So this cancel out with that. So you got 1 plus r over 4. Then after that, minus 1 on both sides. Right? So you got 4 over 3 to the 1 over 20th power minus 1 equal to r over 4. And after that, multiply by 4. So it'd be 4 times 4 over 3 to the 1 over 20th power minus 1. Okay. And after that, you can enter all this in the calculator. So R equal to 0.5795. And then you have to convert into percents and run it off. So move over here, 0.05795. So move over 2 places over. Okay, move 2 places over, so you're going to get 5.8%. Okay, and you run up to that. Okay, let's go to number 9. Okay, number 9, it has 2 parts. Again, it's going to have an investment point first bank up to certain amount of time. You're going to move it to the second bank. Okay, so the first part, you start with principal of $2,000. Okay, and give a 10% interest rate, so it would be 0.1. Right, 10% is 0.1. And then the compound quarterly, that means it's going to be compounded 4 times in a year. Okay, 2 years later, so the T equal to 2 years. So after the amount, and it's going to transfer to the second. So this is the first bank, and this is the second. So whatever amount you have, you're going to transfer over to here. Okay, and this one, the interest rate is 13%. And then what's the value after a total of 5 years? Now the 5 years is total, so you got 2 years over here. That means the second part time equal to 3 years. Okay, so you can 5 years is the total time. So 2 years over here, that means 3 over here, and so you're looking for the final amount. Okay. Okay, so from here, so let's go and work it through. Start with your equation. Then you substitute all the information. And so from here, you punch in all the numbers, you get 2436.81. Okay, so this is the final amount from the first investment. So start at 2,000, put in here for 2 years, you can end up this amount. And then from here, this amount, you're going to bring it to the second bank. So this A becomes the P over here. Okay. So you can, the end amount from the first investment, you bring it over here, becomes the starting investment for the second account. Okay. So now you can go and put in all the numbers in here. So punching all the numbers, you get the final amount equal to 355.65. And because in the very beginning, it asks you to give answer to 3 significant digits. Okay, so 3 significant digits. That means we have to go back to this one. This one, you have to use 3 digits. Okay, 3 significant digits. So double check all your answers. Make sure it's 3 significant digits. Okay, so this one, so when you run it off to 3 significant digits, you get 3, 5. If you run off of it, you get 360. Okay, now the answer in the book is 3550 because they kind of chop off over here, so the answer is a bit off. But either way, it's fine. That's close enough.